Here is basically, well, a couple of things. I am seeing one category. I'm seeing one variable that's broken across 5 categories. So this tells me this is not a two-way table. This is really like it's called a one-way table. And they aren't telling me too much here up here, but this is a goodness of fit test. So what they're saying is that all 5 categories are equally likely. So we're trying to decide. So like I did on that other video, I mean, are they the same? So what we're going to do is first thing you got to do is find the sum of these numbers. So what is that? Let's see if I can do this. 50, 43, 56, 78. And 5 is 78. Isn't that 83? So if I add those up correctly, it's 83. And then, since we're trying to determine whether these are equally likely, we got 5 categories. 83 divided by 5 is 16.6. So my expected frequency for each of these is 16.6. That would be if they were all the same. To get their residual now, we're going to subtract observed minus the expected. Or if you think back to what we did last in chapter 10 with a regression, it's the actual minus the predicted. So it's the same kind of deal. So we're going to subtract each of those. So let's see. So I'm going to do 22 minus 16.6. and 21 minus 16.6, and 13 minus 16.6, and so on and so forth. That's 16.6, not 16.2. So we'll do that subtraction. As you can tell, this is made for a spreadsheet. So if you're at all comfortable using a spreadsheet for this, do it. So instead of having you folks be forced to read my handwriting, what I did is I set this up in a spreadsheet and to finish calculating this. Now, one thing, this is the second time I've done this video, and the issue is what's my open math looking for in this squared residual, Pearson residual. So the way you do that is we're going to subtract these numbers, as I said a minute ago, and then I set up this spreadsheet so we can just look at it. So I did the observed minus the expected, got the 5.4. I did that for each of these. 21 minus 16.6, got that. Then you have to square each of those values. Now, just so you know where we're going with this, I mean, the chi-square test statistic is the sum of the square of the observed minus the expected divided by the expected. And what this column here is looking for is these values that we're going to calculate before we find the sum of them. So to finish this part of it off, there's the differences, the observed minus the expected. Here's the squares of each of those differences, the squared residuals. And then you have to divide each of those by the expected. So what I did on the spreadsheet is I took that 29.16, which is 5.4 squared, and I divided that by that expected 16.6. Okay, and that's what my open math is looking for these answers. So I did the 19.6, 4.4 squared divided by 16.6 gave me that number. Okay. Now the chi-square test statistic is the sum of all those what are the calculations. Okay. And then just to make sure that I was checking to see that I was doing this right, I added in, I got my calculator and added in and calculated and ran the test statistic on that. Let's see, where is it? Right there. And that agrees with that sum, which would go there. Okay, so I hope that answers this my open math question and how to fill that in. and notice that this sum is the same as that chi-square number that the applet gave me. And what I did to use this applet, and you can see the link in the week 11 work, I typed in those numbers, I typed in the expected values, and I clicked calculate, filled this in, gave me that. Done. There's the p-value, pretty small p-value there, and asking us that. Okay, so I hope this helps you complete that problem.